Hi, well, thanks for joining me. We'll take a look at just how do we start graphing quadratics and understand what it is that we're looking at and how would we predict what things are going to look like. So let's start by taking a quick look at Desmos. When we look at a quadratic, it's kind of similar to the idea of y equals mx plus b, where m stands for slope and b stands for the y-intercept, but this has a few more pieces. So our quadratic has this idea of ax squared plus bx plus c. So a is the value that we put in front of the x squared piece, b is the value we put in front of the x piece, and c is the value that we put in at the very, very end. It's the constant, which just like mx plus b, that value is actually our y-intercept. So as we kind of move those things down, if I make c, which is my y-intercept, bigger, you'll notice the graph looks the same. It just sort of moves up and down. So if I move c to be the number 2, you'll notice it crosses the y-axis at 2. If I make c something like -1, it's going to move the graph down, and it's now going to cross that y-axis at -1. And so let me put some steps on there so it's clearly hitting at those values. So you can now see that it literally hits at that number. Now, the other numbers are a little bit weird. Now, A, as it turns out, generally makes the graph steeper or maybe more gradual, but you can kind of notice the graph is moving off to the side as I do that. So larger A values make a very, very steep graph. Small A values between 0 and 1, like 0.5 or 0.4, are going to make kind of a broad looking parabola. And if A ever becomes negative, all that happens is it actually makes the parabola turn upside down. And so again, just like before, a large negative number is going to make a very narrow parabola. A number that is between -1 and 0 is going to make sort of a very wide looking parabola. Now, B is a little strange. B actually has a slightly different effect, is it actually really moves the graph left and right, but it also forces it to pivot around our C value. So you'll notice this thing has this y-intercept at 0, 4, and I'm not going to move that number at all. And so as I move this around just a little bit, you're going to notice that the graph is going to be forced, since I'm not going to move what that C value is, it's going to force to keep that C value where it is. So you can see that the graph moves left and right, but it's sort of like it has to somehow hug that value 0, 4 as I move around. And it wouldn't matter no matter what I do, as if I make the graph go up and down. As I move that A value to a positive, if I move B around, it's still going to be forced to move through those numbers. But of course, if I change my C value to a different value, like say 1, then all of a sudden it's going to pivot around 0, 1, but it's still going to force it to move around that number no matter what I do. It has to go through that value. So that's just a little bit of an idea. It always goes through that C value. A makes it steeper or more gradual, and it also tells you whether you're going to go upside down or not. So let's go ahead and take a look at a few problems, but we're only going to focus on problems where A is either equal to 1 or -1. Now, I'm going to start with a little formula here. And so when we do that, remember, we want to look at what values we have. And so the number in front of x squared is going to be called A. And so in this case, our A value is 1. My B value is going to be -6, and my C value is 2. And so in class, we introduced this idea that we want to look at the opposite of B divided by 2A. So we always want to take whatever B is and change that sign. So it's x is equal to the opposite of B over 2A, and the opposite of B is +6. And if I double A, I get 2, and 6 divided by 2 is 3. So what's going to happen is I'm going to center a table around the number 3. Now, my apologies if this ends up being a little bit messy, because we have a lot of work to do for these particular problems. But what I'm going to do is I'm going to plug in 3 for all of my x values. Notice it says x equals 3. So I'm going to do 3 squared, 6 times 3, and plus 2. Well, that gives me 9 minus 18 plus 2. Now, if I take 9 and I subtract 18, I get -9. And if I add 2 to that, I get -7. So 9 minus 18 is -9. -9 plus 2 is -7. This value is called my vertex. So if I go out here and I find x equals 3, that's going to be my line of symmetry we talked about in class. So here's my line of symmetry at x equals 3. I'm going to go down to this coordinate. This is my vertex. It's the point on the graph, 3 comma -7. That's what it's going to be. Now, the reason we do that is to save ourselves a huge amount of time, because look at how much effort it was just to get this one point. But I'm going to move over 1 and find the number 4. So let's go 4 squared minus 6 times 4 plus 2. So I'm replacing each of the x's with the number 4. Well, 4 squared is 16. 16 minus 24 plus 2. Well, 16 minus 24 is -8. And -8 plus 2 is -6. So I could go over here to 4 and put a dot at -6. But what happens because of this line of symmetry, if I go the same distance on the other side, I also would get -6. So even though it took me some effort to get that one point, I get another point on the other side. So now let's try 5. And of course, whatever I get for 5 will also be true of the number 1. So we could plug in either value, honestly. So let's see, if I plug in 5 for x, that would be 5 squared minus 6 times 5 plus 2. So that's 25 minus 30 plus 2. 25 minus 30 is -5, and -5 plus 2 is -3. So these are both going to be -3. So if I go to the right 5 and go down 1, 2, 3, I've got this spot. And if I go over here, see, this is 2 units away from my line of symmetry. So I'm going to go over here. Those are 2 very nice values. Now I am going to go ahead and get one more, and I'm going to plug in the number 6. And I don't have a lot of room to do that. So I guess I'm going to maybe put that right up here. So I would do 6 squared minus 6 times 6 plus 2. Notice I replaced that x with 6 and that x with 6. I got 36 minus 36 plus 2, which gave me 2. Cool. So I know that if I go to the right 6, 3, 4, 5, 6, I would go up 2. And then by symmetry, 1, 2, 3, 1, 2, 3, it would be right here. Now there's a couple of reasons I wanted to do that. And now I can just go ahead and play connect the dots with this graph right here, the nice smooth curve that goes through it. And I wanted to highlight a couple of things with you as we look through this. Now keep in mind, my curve was right here. Notice my A value, my B value, and my C value. Notice the C value is sitting right there. So I did a lot of work, and I found that it actually crossed that y-axis at 2, which actually confirms that I did this problem well. Now, again, that doesn't always mean that I did everything perfect, but it's an awfully good, it seems to indicate that I did well with that problem. So let's look at this problem right here, this next problem. Okay, so that's the first one. So we're going to go through the process of finding what A is. So A is the number in front. That's a 1. If there's nothing there, it's a 1. B is 4, and C is 5. And so what I wanted to do is use our little formula, which is opposite B over 2A. So the opposite of 4, of course, is -4. 2 times 1 is 2. So my line of symmetry happens at -2. So I'm going to put a little dotted line here at -2. And I know that everything in my graph is going to be centered around that -2. So what I want to do is I want to plug in -2 everywhere where I saw an x. Now, when I do -2 squared, I get 4. 4 times -2 is -8 plus 5. Let's see, 4 plus 5 is 9. And 9 minus 8 is 1. So if I go to -2 comma 1, that's my, again, vertex. That's the place where my graph is going to start. So I know that if I go to the right one or the left one, so hopefully I'm not writing so small you can't see, but if I go to the left or right one unit, it's going to do that. So I'm going to go ahead and plug in -1 for x and see what happens. So -1 squared is 1. 4 times -1 is -4. So if I put that all together, 1 plus 5 is 6, and 6 minus 4 is 2. I think I made a mistake there. 1 squared, -4, that's 5. Nope, that was right. It was 2. So I go over here and I go to the number 2. Okay, nice easy value. Well, let's try the next one. Well, this one I don't have to work so hard because I know if I plug in 0, I'd get 0 plus 0 plus 5. We already know that that's quote unquote our C value. So these are going to be the same. I don't know why I wrote that number there. That should be a -4. So if I go 0, I could get the number 5. That's my y-intercept, and that makes good sense because if we try it, we tried 0 squared plus 4 times 0 plus 5 is 5. And maybe one more value. I think I'll throw it out here to the side. Let's try the number 1 way out here, which should match perfectly with -5. So let's see, let's do 1 squared plus 4 times 1 plus 5, and I got 1 plus 4 plus 5, which looks like 10. So it's way up on the graph that the number 1 gives me 10, but also if I go over 1, so you know my line of symmetry right here, if I went over 1, 2, 3, so 1, 2, 3, so that would be sitting right here. So I can do a nice little graph right here. Now, one of the nice things about these things, as you're paying attention, and I hope that you are, is there's a few things that should happen if we have done the mathematics right. Whenever you find your line of symmetry, which we did right here for our vertex, we did that on this one and we did that one on this one. What I want you to notice is the symmetry in the graph. Notice as we go across, these numbers match and these numbers match. But there's something else that happens that's really nice. As you move along in this direction, you added 1, and then you added 3, and then you added 5. Well, that is a pattern that must happen if we do our parabolas correctly. And in fact, we do it so much that usually we just make sure we do a good job on that first one, and then the other ones follow. So notice the way we move this way, and it went up 1, 3, and then 5. And it does that not just in one direction, it does that in both directions because of the symmetry. So we have our nice little 1, 3, 5 pattern that we discuss a lot in class. So the last problem that I'm going to do is I'm just going to go ahead and use that little fact because I know since it works so well that I'm just going to go ahead and do that. And so we're going to go ahead and find out what A is, what B is, and what C is. Remember, A is the first number, B is the second one, and C is the last. We do our little formula, which is the opposite of B over 2A, which would be, let's see, -2 over -2, because 2 times A would be -1. So I got 1. So my graph is going to be centered around the number 1. Okay, so let's see what we got. So if I center it around the number 1, it says the opposite of 1 squared plus 2 times 1 plus 5. Now, I will say that's a little tricky because I didn't square the negative. All I squared was the 1, and the negative happens afterwards, which is an easy one to mistake. So I got -1 plus 2 plus 5, which is 6. So I've got my line of symmetry happened at x equals 1. And it has a vertex at 1, 6. 1, 2, 3, 4, 5, 6, right there. Now, what I know is if I've done this right, is if I go over 1 in either direction, it should, instead of going up 1, it's going to go down 1. So again, if I'm at 6 and I go down 1, I should be at 5. Well, we have a little check step right there because notice I said C, or my y-intercept, is 5, and look where it hit. It hit right at 5. So it kind of indicates that I probably did my vertex okay because it matches. But then after going down 1, I'm going to go down 3. So I'm at 5 and I go down 3. I'm going to land at 2. So at 3 and -1, I'm just moving along here. I'm going to go over 1, down 1, 2, 3. Over 1, down 1, 2, 3. Notice the symmetry. These two dots are 2 units away from that line of symmetry. And so if I went down 1 and then 3, the next step as I go to the left and right would be to go down 5, which would be at -8. Excuse me, down 5 would be -3. That was kind of terrible, wasn't it? I'm at 2, not -2. So I want to go down 5. I'm going to be at -3. 1, 2, 3. Let's see, how do we do? Go down 1, 2, 3. So let's see, go over 1, down 1, 2, 3, 4, 5. That fits the pattern that we said. Now, one thing that would be really, really good, again, this isn't what everybody does, but people that want to get really good grades in classes and people that want to go on to Algebra 2 and be successful tend to want to check these things and make sure they've done well. So if you look at 4 comma 3, actually 4 comma negative 3, I got that by using this pattern, but you know what? If I made a mistake anywhere in there, I would be off. So what I'm going to do is I'm just going to do one time. So notice I only plugged into this problem one time. I'm going to go ahead and plug in one more time, and I just picked this value just at random, and it could be another value, but I'm going to see what happens if I plug in the number 4. So it says the opposite of 4 squared plus 2 times 4 plus 5. And my question is that going to, in fact, give me the number -3? And -16 plus 8 plus 5, in fact, is -3. And so that actually is going to be the value we are hoping to get in that problem. And so that's all we have for today. And I will see you back in class. Bye-bye.